Hello everyone, and welcome to another simple science video where we aim to explain simple scientific concepts. And in this video, we are going to be looking at moments of a force. So, what are moments? Well, let's look at the force in general. Well, forces can make objects move in straight lines. And often happens when the force acts through the center of the object. But a force can also make an object rotate, like how we can push against a door, and then it rotates about its hinge. So forces can also make things rotate, and the effectiveness in which the force makes it rotate is also known as its turning effect. And its turning effect is known in physics as the moment of the force. The turning effect is known as the moment of the force. Okay? Now let's look at a force of 10 newtons acting on a beam and look at a force of 20 newtons acting on this beam in the same position but with twice the amount of force. So you can expect that the turning effect or the moment of the force is twice as much. So as you increase the force, you increase the turning effect, such as trying to push on a door with a greater amount of force. You're going to push it with a greater turning effect, aren't you? You can feel it. In addition, if you were to push onto a beam with a further distance away from the hinge, it becomes easier to push. So as you increase the distance of the force from the pivot, you increase the turning effect. So in general, the force and the distance from the distance from the pivot is F and X. And in physics, we define the moment of a force as a product of the magnitude of the force and the perpendicular distance of the line of action of the force from the pivot. In this situation, it's Fx. And in my diagram, I will indicate F as force and X as the perpendicular distance of the line of action from the pivot. You see the line of action, I indicate it with a dotted blue line, and the perpendicular distance is that right angular distance from that dotted blue line to the pivot. And that is X basically. And the concept of perpendicular distance of line of action from the force is very important, especially when you're looking at forces that are acting at an angle onto a beam. So look at it. The force F acts at a distance of x from the pivot, but at an angle of a from the vertical. Now, we want to find the perpendicular distance from the pivot of the line of action of the force. Remember. So, how do we find this out? Now we have to draw out the line of action of the force, dot blue line, and then we find the perpendicular distance of that blue line from the pivot, which is indicated by the dotted left line, the dotted black line on the left with a right angle on it. That's perpendicular distance from the pivot. And through basic trigonometry, we can see that the angle is also A, and we can therefore derive that distance is x cos A. So that distance is the distance of the line of action from the pivot, and therefore the moment of the force at an angle is force times cos A. Okay, where A is the angle of the force from the vertical. Remember, that's how we define it, right? Okay, so that's basically the moment of a force at an angle and a moment of force perpendicular to the beam. And let's look at an example. A force of 5 newtons acts at a distance of 1.1 meters from the pivot. Remember, the moment of a force is equal to Fx, right? And we need to find the force and the perpendicular distance from the line of action. And this is easy because the distance from the line of action is 1.1 meters. But the moment of the force, so therefore, is equal to 5.5 Newton meters. Okay? Remember, the perpendicular distance from the pivot is always x cos A. But in this situation, A is equal to 0. And when A is equal to 0, cos A is equal to 1. So 1.1 cos A is equal to 1.1. Now, more often you'll be asked to find the net moment of a force. That means there's more than one force acting on a beam or a structure. And what you have to do is you have to sum up the moments, and if the force is acting in an opposite direction to a positive indicated force, you have to make that force negative. Such as if you want to make 5 newtons as a force, which is positive, you have to make 10 newtons negative. So you have 5 times 1.1 add minus 10 newtons times by 1.1 meters from the pivot. Remember, 1.5 meters from the pivot, sorry. And this should give you a turning effect of minus 9.5 newton meters. So you would expect this thing to rotate anti-clockwise. Now let's look at a force acting at an angle. Remember, the moment of a force is equal to force times distance times cos of the angle from the vertical. Remember, the x cos A is basically the perpendicular distance of the line of action from the pivot. So basic trigonometry says that is the length that we need to find out. That is x cos A. And we know A is equal to 30, and that small angle down there is also equal to 30. So x cos A is equal to 4 cos 30. And you want to multiply it out, 5 times 4 times cos 30, which should give you 17.3 Newton meters. So this thing is turning with a moment of 17.3 Newton meters clockwise. Thank you for watching my videos.